Hi everyone, I'm Darshan Senthil, and in this video we're going to be talking more about trig. So in this video we're going to be specifically talking about the unit circle. Now this is one of the most annoying concepts for me in trig because it's just so much memorizing, and the worst part is that you have to have it in your head for like the entire of your trigonometry, for your whole trigonometry career, so you can never actually forget it. So a lot of things you can in math you can just like learn them and then forget them for a while, then relearn them when they come back. But the unit circle you need to actually know it until you finish trigonometry, which is a pain in the butt. But yeah, it's kind of necessary for trig, and I don't like it very much either. So I feel that, but nonetheless I feel that schools, and my school in particular at least, I feel we put too much emphasis on the circle itself and like memorizing it, that we kind of forget how it actually works, like how you find stuff, how you derive things from it. So I'm just going to try to introduce you to how the unit circle works. So hopefully you're not just thinking of it as like something you need to memorize. So you actually see why we use a unit circle, how it relates and stuff like that. Okay. So I'm going to try to make this as interesting as possible. So okay, let's get started. So let's talk about why we need a unit circle. So like why? So let's say I asked you this question. So I said find the sine of 35 degrees. You would say, okay, give me a triangle, right? So if I gave you a triangle like this, like a right triangle, 35-degree angle, like 6 and maybe not 6, but like x and y, I'll give you two sides like that, you would find the 6 trig functions, and those could be like random numbers. Okay, but what if I asked you for something a little more complicating, like the sine of, let's see, 190? Now that doesn't fit into a triangle. Remember, the sum of all the angles of a triangle is only 180, so you can't possibly have a 190-degree angle on a right triangle. But you can have it elsewhere, and that is what we use the unit circle for. And also I could ask you something else, like I could ask you for like the sine of negative 30 degrees. Yes, negative angles do exist, they're not just nightmares. So these are the sort of things that you cannot get in a triangle. So you don't get these in triangles, and that is why we need the unit circle. Okay, and let's just take a look at what this marvelous unit circle looks like. So this is the unit circle. It's by itself is nothing really extraordinary, but the only thing that you really need to know about this thing itself is that it's just a regular circle with radius of 1. So it's just a circle with a radius of 1. And if you don't know what that means, that just means that from the center of the circle, the distance between the center of the circle and any point on the circle is just going to be 1. Okay. And another thing you need to know, that's one thing. Another thing you need to know is that it's on a graph. I feel that this is one thing that people may not state enough, because it's very important to know that the circle is actually situated on a graph. It's not just an arbitrary circle floating around somewhere. It's on a graph. So we will be working with like coordinates and stuff, and it's really important that you know that it's on a graph. So don't be like, where the hell did these coordinates come from? Okay, so now let's get started. So as you can see on the circle, we could draw a line like this, and we can find angles like this. So this is like this is probably somewhere around 190 degrees, or you could find something like this, like, which is about negative, I don't know, like 110 degrees perhaps, somewhere around that. So you can find a lot of different stuff like this. And so as you can see, now we can actually represent these angles somewhere. So now how we actually find the trig function of those angles let's get into that. We'll get into that right now. So let's just say I gave you an arbitrary coordinate on this circle, and as with the right triangles, you cannot find the 6 trig functions unless you're given like side length. Similarly, you cannot really find the trig functions of any angle on the unit circle unless you're given a coordinate. Okay, so let's try something a little bit like, yeah, let's try something over here. So if that is like let's call that coordinate x comma y. Okay, and it's on the circle. So what we can do is we can draw a line. Oh my god, I'm bad at drawing lines. Draw a line. Again, it's not totally straight, but you get the picture. You can draw a line from the origin to the point there. Take this angle, call it theta, and I'll say find the 6 trig functions of theta. What are the 6 trig functions of theta? And to start with, this may look a little bit difficult, but then we need to start putting things into place so we can actually find them. Okay, find what we need. So first, let's just put down everything we know. So we know that this line here that connects the coordinate and our origin is a radius, right? Because it's a line from the origin, beg your pardon, to this point on the circle. So hence, and because of the definition of a unit circle, it states that it's just the unit circle is a regular circle with a radius of 1. We know that the circle has got this side length would be 1. Okay. And now what else do we know about this circle? Well, let's just start off by looking at like this. What do we know about this coordinate? So what do these coordinates tell us? So what does the x and the y tell us? So let's just go back to the definition of a coordinate. So the x coordinate in algebraic notation for coordinates, the x coordinate always tells us how far left or right we've gone, right? Right? So this x coordinate will tell us how far left or right we've gone. So that will tell us this side length over here. So if we drew like a perpendicular line down here, that would tell us this length right here. Okay, let me write that 1 a little bit neater. So that will be 1 and this will be x. And what does the y coordinate tell us? The y coordinate tells us how far up or down it goes, right? So this line here is going to tell us how far up or down this coordinate is from the x-axis, or how far up or down it is from the origin. So, and by this diagram we know it's gone up y units, so we're just going to make that y. Let me make that black. So it's gone up y units. And does this look familiar? Well, it's a right triangle, right? So now we can just evaluate the 6 trig functions using SOHCAHTOA, which I hope you remember. Sine theta is opposite over hypotenuse, which is going to be y over 1, which is just simply y. Cosine of theta is going to be adjacent over hypotenuse, which is x over 1, which is just x. Tangent of theta is going to be opposite over adjacent, which is y over x. And okay, let's just make that 3. I'm not going to do 6. So those are the 3 trig functions. Okay, so now I hope you noticed something. So if we had this, so if these were not just x and y but like actual numbers, then this would actually hold true for that as well, because the hypotenuse is always 1. Then if we had just any other coordinate, like let's say this was 3, 4, then the sine of that is just going to be the y coordinate, or 4. The cosine is going to be the x coordinate, or 1. And the tangent will be these two divided. So keep in mind that these apply for any values any coordinates xy on the circle. Okay, so this statement we've made, that the sine of theta is going to be equal y cosine is x, this will apply for any coordinates xy on the circle. So it could be over here, it could be over here, but as long as it's on the circumference of the circle, we know that it's going to be this. Okay, so that's just a basic overview of how you find stuff on the unit circle. I'm going to do some examples and maybe go a little bit more in depth in the next video. Okay, thanks for watching.